Alrighty, welcome back to Year 12 Mathematical Methods. We're looking at 14C, finding the sample size today. This is a pretty interesting exercise in that it puts forward, it says, like how many times might you need to roll the die to be reasonably sure of observing a 6? Or on the other hand, might be like a lotto ticket, how many you must buy to be reasonably sure that you are going to win a prize. These are interesting things. So work example number 8 is looking at something like this. It says the probability of winning a prize in a game of chance is 0.48. We're going to find the answer to the following two things. It says what is the least number of games that must be played to ensure that the probability of winning at least once is more than 0.95. And secondly, we're going to be finding out what is the least number of games that must be played to ensure that the probability of winning at least twice is more than 0.95%. Or 0.95. Now, a lot of this can be done on the calculator and using binomial distribution, so we'll be checking that out. Alright, so it says here, since the probability of winning each game is the same each time the game is played, this is an example of binomial distribution. Cool. With the probability of success being 0.48. Nice. Now, as we know from this, the probability of failure is going to be 1 takeaway p. In this case, it would be 0.52, and that will come in useful to make the calculations a little bit simpler. So the first part was asking that the required, the smallest value of n was such that the probability of x had to be greater than or equal to 1. Was that one? So at least once we were looking at winning. And we wanted that to be greater than 95% or 0.95. So writing this out, we've got the probability of x being greater than or equal to 1, and that being greater than 0.95. If we think about probability of x being greater than or equal to 1, that really is the same as 1 take away everything that's less than that, which is probability of x being equal to 0. Okay, so that's the other way of thinking about that. 1 take away the probability of x equals 0 is going to be greater than 0.95. On the other hand, if we think about just the probability of x being equal to 0, it's going to be 1 take away this 0.95. So probability of x equaling 0 is going to be less than 0.05. Okay, now once we get to that realization, again we can use binomial distribution to work out what the probability of x being equal to 0 is, with a probability of 0.48. Now in this particular case, it's very similar to what's down here. You would do this probability distribution or binomial distribution. This does simplify down just to 0.52n is the probability of x equaling 0. So once we've got that, it's a matter of, to find out what the value of n is, we do need to use logs to do that. So what we're going to do is we're going to take the log of both sides of this equation. So we're taking the log to the base e of this side, we're taking the log to the base e of this side. We know that if you've got log to the base e of 0.52 to the power of n, that n can come out the front here as such, and then from there we can divide this side by log 0.52 and divide this side by log 0.52 to find out what n is. Now again, to do this and get the approximation of this, we can use our calculator. So again, here, if you've got the log, what was it, of 0.5 or 0.05, and we're dividing that by the log of 0.52. We'll have that decimal approximation. We get the 4.58 as indicated there. So in this case it says, thus the games must be played at least 5 times, we have to round it up, to ensure the probability of winning at least once is more than 0.95. Cool. Next one here, it says the required answer, and this was for to ensure a probability of winning at least twice is more than 0.95. So again, the probability of x being greater than 2, sorry, x being greater than 2 is more than 0.95. Now again, another way of writing this is considering having the things that aren't greater than 2, so things that are less than 2, and that would be the opposite of that, so 1 take away that, which would be 0.05. When you consider the probability of x being less than 2, what we're really looking at is the probability of x being equal to 0 and the probability of x being equal to 1. We can calculate those using the binomial distribution. So working out the probability of x being equal to 0, it's going to be this here. Working out the probability of x being equal to 1 using binomial distribution, it's going to be this here. And that's from what we learned in the previous lesson. This does simplify down to this equation here. And so ultimately, to work out the answer for the smallest value of n, we need to find out when this is less than 0.05. Now again, we can use our calculator to do this. It's a matter of making sure that we do type it into the calculator correctly. So on the Classpad, we would use the solve function. In this case, we've got 0.52 to the power of n, and we're adding on 0.48 multiplied by n multiplied by 0.52 to the power of n take away 1. And when we have this, we're working it out for less than 0.05. For the sake of this, we'll just do it equal to 0.05. Remember, you need to put a comma in here and tell the solve function what variable it is you want to solve, and it's n in this particular case. And we're going to close that bracket and run that. It says more than one solution may exist. Thank you for that. In this case, it's saying n could be equal to negative 1 point something. Remember, it has to be a positive number of games that were played. So the first positive value here is 7.7985 as indicated. So therefore we would say they'd have to play at least 8 times to ensure that the probability of winning at least twice is more than 0.95. Alrighty. Another cool thing that you can do is use your calculator as follows. So you can go to use a binomial distribution function within your calculator. So like we've been doing in the past, you can go to interactive, we can go to distribution, we can go to discrete, binomial CDF. Now if we're looking at the second example where we're looking for values that were greater than or equal to 2, or probability of x being greater than or equal to 2, where p was equal to 0.48, obviously what you would do, your lower value is going to be 2, your upper value is anything that's greater than 2, so we just have that as x. Number of trials we really don't know yet, that's what we want to find out, so we can leave that as x. And as we said, the probability of success there in that particular case is 0.48. Now, that's just really, the purpose of doing that is just to get this function on the screen. So what we're going to do is we're going to copy that and we're going to put it into a table. So again, to do this, we're going to go into the graphs and table section. Clear anything that's not required there. So in Y1 here, we're going to paste in that binomial distribution function that we got the calculator to create, which is done there. Make sure you tick it. Now, we're not graphing it. What we want to do is create a table. So we're going to click on the table button, which is this one here. And you can see here it spits up the table until the probability, and we can look at when the probability first exceeds 0.95. So here at 5 it's 0.78. Let's go down. Let's go down here. Okay, so we might have to make the table a little bit larger, so we're going to go more x and y values. So start at 1, let's go to 10, that'll be helpful. If that doesn't come up, now we should be able to go down. Yep, so we're looking for whereabouts it is first exceeds 0.95. You can see it exceeds 0.95 here when the value is 8. So that's helpful to know and generate in this particular case. Alright, thank you for listening. I hope you have success with this exercise. Bye for now.